Assalamualaikum and hi. My name is Muhammad Sharkawi from Group 9 and today my group will be presenting and demonstrating about the concept of energy conversion, specifically from kinetic energy to potential energy using the concept of pendulum. But before that, I will be explaining about the definition of energy work and energy conversion. Energy is defined as the ability to do work, which is the ability to exert a force causing displacement of an object, such as here. While work is said to be done when a force produces a displacement in the body and acts in any direction except perpendicular to the direction of displacement. And energy conversion is the process of changing energy from one form to another. In physics, energy is a quantity that provides the capacity to perform work or moving or provides heat.
Assalamualaikum. Hi guys, my name is Muhaimin and I'm gonna tell you all the simple definitions of kinetic energy and potential energy. So first, kinetic energy. Kinetic energy is the energy an object has because of its motion. The amount of kinetic energy depends on two things: the object's mass and how fast the object is moving. Alright, imagine you have a soccer ball and you kick it really hard. When you kick it, it starts moving fast, right? Well, that energy is gets from moving so quickly is called kinetic energy. So the faster something goes, like a racing car or a spinning top, the more kinetic energy it has. Now let's move on to potential energy, shall we? Potential energy is the stored energy an object has because of its position or condition. Picture a bowstring pulled back with an arrow. So, the energy stored in the band bow is potential energy. Similarly, potential energy is like a hidden energy reserve in objects based on their position or state. It can be gravitational, elastic, or any other forms. This energy can become kinetic when the object's position change, releasing that stored potential energy.
Okay, hi guys, so today I'm going to show you guys an experiment about the conversion of energy. As we all know, energy cannot be destroyed, but it can be converted into another form. As example, heat energy can be transformed into electric energy. While in this demonstration, we're going to show you guys how we can transform a potential energy into kinetic energy. Okay, boleh lepas. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zaim Nazif bin Muhammad Zamran, and I'm here today to explain what Shafiq has just demonstrated. The simple pendulum system, by theory, will always be swinging without any external forces that leaches onto the energy. As we have already known, energy is indestructible. It cannot be created and cannot be destroyed, but we can change its form. At the highest point of a pendulum system, it will reach maximum potential energy but no kinetic energy. However, at its lowest, it will reach maximum kinetic energy but no potential energy. Under normal circumstances, a pendulum system will gradually slow down from the parasitic forces like friction, air resistance, and heat. If recorded, it will create a damping graph like this, where the pendulum gradually comes to a halt. However, if we somehow able to eliminate every single parasitic forces and keep all the energy inside the system, we will create a pendulum that keeps swinging on forever across the flow of time, as if stuck in a time loop. And if recorded, it will create a graph like this, where every single amplitude is consistent. And that's about it. That's all for me. Thank you.
Hi, my name is Muhammad Said Ramadan bin Ramli, and I will be explaining the mathematically expressions on the conversion of potential energy to kinetic energy. Kinetic energy is 1/2 mv to the power of 2, whereas for potential energy is mgh. And the conversion of potential energy to kinetic energy occurs as the pendulum swings back and forth. The energy is influenced by the changing of height and velocity during the pendulum's motion. So I'll show you an example of how it goes. Alright, so here we have the formulas for potential energy, which is equal to mgh, and kinetic energy is equal to 1 over 2 mv squared. So as we can see here, over here, this is the initial point. The initial point here, the kinetic energy is equal to 0, and the potential energy is, we can count it by the formula mgh. So the m stands for mass of the dark ball, which is in kilograms. What we got was 400 grams, so we convert it, which will be 0.4, and g is the gravitational acceleration, which is 9.81. Okay. And the height over here is the height from the ground, which was 1.8 meters. So alright, so we can count the potential energy, which is 0.4, 9.81, and 1.8, which is equals to 7.06. So a question will ask us about the velocity of the object. Okay, over here at the middle point here, which is where it has the highest maximum kinetic energy, because when the ball swings, it converts its potential energy to kinetic energy. So we can use the kinetic energy here with 7.06, because it's the same value as the first one. So when it converts here, potential energy becomes 0, and all the energy converts into kinetic energy, so we'll get the same. So we'll put this in the formula. 7.06 equals to 1 over 2, m is 0.4, and the velocity squared. So this is simple math. Just put it in calculator, and we got 6 millimeter per second. Okay, and that's it. So we have potential and kinetic energy. This is the formula, and this is how we calculate the velocity, and we can find the potential energy here.
Hello, my name is Muhammad Luqman Mu'min. You can call me Luqman. Today I will show you a derivation of formula kinetic energy and potential energy. So let's go. At first, we will doing derivation for potential energy. We consider the object on the earth, and we want to lift up the object at a certain height, which is h. By using the work formula, work equal to Fs and S equal to height. F equal to mg. So the new formula we will get work equal to mgh is equal to potential, gh is equal to potential energy. We go to derivation for kinetic energy. We consider the moving object at displacement, which is s, and the weight is m. The initial velocity of the object is equal to 0, and the final velocity is equal to v. Using the formula, work equal to Fs and F equal to ma, so the work done is W equal to MAS for the first equation. For the second equation, we will use third equation of motion, which is V the power of 2 minus U power of 2 equal to 2AS. We will fill the value and simplify the equation to become V power of 2 equal to per 2S equal to A for the second equation. Then we will solve the equation, the SE simultaneous equation, and it become W equal to 1 per 2 mv the power of 2 is equal to kinetic energy.